So this is the first problem of today's contest, Diff 2 contest. And in this problem, we are given that so Greenlandia has been hit by flooding and now has to reconstruct all of its cities. Now, Greenlandia can be described as an N cross M matrix, and initially all of its cities are in economic collapse. Now, the government can choose to rebuild certain cities. Additionally, any collapsed city which has at least one vertically neighboring rebel city and at least one horizontally neighboring rebel city can ask for aid from them and become rebuilt without help of the government. So this is just the formal definition of it. And if the city is located on the border of the matrix and has only one horizontally or vertically neighbor, then we consider only that city. Like if let's say this is the city, so this city doesn't have any like vertical any city which is vertically up to it. So you cannot consider like okay, there's like there can be aid from there. No. So the government wants to find the minimum number of cities it has to rebuild such that after some time all the cities will be rebuilt. So this is a very simple problem. See, let's say we have a grid. Just a second. Okay. So let's say there's a this grid. So if we want all the cities to be rebuilt, each row and each column should have at least one city built. Why? See, if let's say I left this row completely or this column completely, like there was no city rebuilt in this column. So after a point, maybe I'll be able to rebuild all of these cities, but all of these cities will be left. Why? Because for each city to be built, there should be a vertical and at least one horizontal city that is built. Like that from there that they can take aid. But if none of the cities in this column were built, then this complete column will be left out. Similarly, if let's say I left one row completely, like I didn't build any of the cities in this, the government didn't rebuild any of the cities in this row, then everything eventually maybe like it will be rebuilt here, but none of these will be built. So we have to choose at least one city from each row and from each column. So what is the best way to do this? Like whatever is maximum of number of rows or number of columns is your answer. In this example, let's say we have 5 rows and 4 columns. Pick from each row one. And like you can see how will the cities get rebuilt. See, this will get rebuilt because of these two. Now this will get rebuilt because of these two, these two, these two. So all of these blue will get rebuilt because they have a vertical and a horizontal. Now this will also get rebuilt because again a vertical and a horizontal. This will get rebuilt. This will get rebuilt. This will get, then this will get. So okay, please don't annotate. Like whoever has done this, kindly remove this. So then this will also get rebuilt. This will also get rebuilt. This can also, no, see, there is no point in turning off the annotation. You are not here to annotate at first, right? So why should I enforce something which you're not supposed to do? Like, what's the point of you annotating something? Like, in some cases, like there have been sessions in which I have asked students to directly annotate on the screen when I am not understanding their doubt. So it's something like which we can use, right? But don't note like if you like I know like it would have probably been a mistake by someone like who is new to Zoom. But like don't experiment during this session, okay? Like don't try new features on Zoom. So this will get rebuilt and this will also get rebuilt. So this way, if we ever have selected at least one city from each column and like each city from like one city from each row, then we are able to do this. Like we will be able to rebuild all the cities. So the answer is nothing but maximum of n and m. So is this clear to everyone? If anyone is having any doubt, like you can write in the chat. Okay, I think it's clear to majority of the people. So let me show you the solution. Okay, why is it not minimum? Not like why is it not minimum and like and maximum? Because see, if you took minimum, you would get 4. Let's say if you got 4, you are selecting these 4 cities. Like eventually one of the rows will be left out. You didn't pick one row. Like how can you rebuild this row? There is no way that you'll be able to build cities in this row if you would have chosen only 4. So you would have to select from each row one city and from each column one city. So whatever is maximum of these. Is it clear? So let me show you the solution. So this is the solution. This is the implementation. Just take n and m as input and print maximum of those two. So now going to the next problem. So in the next problem, we are given that we have a tree. And in one Zelda operation, we can do the following. Choose 2 vertices of the tree U and V. Compress all the vertices on the path from U to V into one vertex. Now, in other words, all the vertices on path U and V will be raised from the tree and a new vertex W will be created. Now, then every vertex S that had an edge to some vertex on the path U will have an edge to vertex W. That is the new vertex that was created. So in this example, let's say the path 5 to 1 was chosen. So this is the node that was created, and all the other nodes are now linked to this, which were earlier connected to nodes 1 to 5. So we have to find what is the minimum number of operations. So this is also a very easy observation problem. See, let's say there is some tree like this. Like I'm assuming it's rooted at some point. So eventually you just need one node out of all of these nodes. So let's try to look at, like eventually all these leaves, these are the leaf nodes. These leaf nodes will also belong to that one big node, right? Like my point is, if you want all of these leaf nodes to be in that one big node, there should be one Zelda operation in which each of these are included. So the point is, there should be a Zelda operation in which this was included, this was included, this was included, not this. This was included, this was included. So there are 5 nodes, and how many in one Zelda operation, how many leaves can you choose? Maximum 2, right? A simple path can have 2 endpoints. You cannot have 3 endpoints for a simple path. So like this is not a simple path. So if at max you can choose 2 nodes in one Zelda operation, 2 leaf nodes, what is the answer? Number of leaf nodes? Leaf nodes divided by 2. Now you just need to be sure that you are taking seal of this. Why seal of this? In one operation, maybe you chose these 2. In one operation, you maybe chose, let's say, these 2. Everything is collapsed into one. Then in one operation, you chose these 2. So after this point, everything on these paths will be a single node, but this will be left out, right? So you'll have to do one extra operation for this and your root node. So that thing will be 3. So that's why 5 divided by 2 seal. Is it clear? Yes, no?
Yes.
Okay. So let me show you the implementation. So this is the implementation. In this, first take n as input, then like there are n minus 1 edges in the tree. And while I'm taking it, I'm not actually making a tree, I'm just like having this degree, it doesn't make like it shouldn't be in degree, it is simply degree, like the number of edges that are connected to the ith node. So once that is calculated, I'm just counting the number of nodes which are in degree as 1. These will be our leap nodes. And my answer simply is answer plus 1 by 2. This is simply CL of answer by 2. So I hope this is clear, right? Okay, so let's go to the next problem. So in the next problem, we are given that given a string S of length n, in one operation, you can select the lexicographically largest substring, not substring, subsequence of string S and cyclically shift it, like cyclically shift it to the right. Now, our task is to calculate the minimum number of operations it would take for S to become sorted, or report that it can never reach a sorted state. So this is the definition of what is a lexicographically smaller string or lexicographically larger string. So A and B are like A is lexicographically smaller to B if it appears before B in dictionary order. And by cyclically shifting, they meant that if the string is this thing, last character will come at the front and all the other characters will shift one time towards right. So now let's say we have the string for the first operation. For the first like what is the one operation? We need to choose the lexicographically largest string subsequence. Like we don't have a choice there. And by the way, how many sequences can be lexicographically largest in this? Any idea, anyone? How many ways do you think there are to choose the lexicographically largest subsequence for the first time? It's one, right? Let's say this is the subsequence. You cannot say that there is one more way. Like let's say this was C, this was B, this was A. You cannot say like I can choose maybe this, and this. This is also A. This is not true because then your subsequence, lexicographically largest subsequence would have been this only. And you cannot say something like, okay, but maybe I can do this thing. There is a B here. Then again, your lexicographically largest subsequence would have been this thing. So there is only one lexicographically largest subsequence for the first time. That thing is clear. And that is not for just for the first time. A string will have only one lexicographically largest subsequence. And each time you can select only that only. You don't have a choice. And in one operation, you can just cyclically shift these characters. Like this will come here and all of these characters will go here. Okay, lexicographically is something like if you have, let's say, 5 strings and you arrange them in order of dictionary, like what happens in dictionary? First A comes, then let's say A, B, all of these, right? And then something like B. B comes after all of these. Like this is lexicographically smaller than B. Then B, something like B, C, B, C, B, B, C, C, and then C. So this is lexicographic order. Like you will get the straightforward idea using that, like reading that definition also. It's nothing but if you sort these strings according to dictionary order, like how would they would have appeared in dictionary. That is called lexicographic order. And lexicography largest simply means that you have to choose the biggest string. So like I have explained, there is only one string. Like try to make a string which is having two lexicographically largest. You won't be able, because then you're not choosing the lexicographically largest. If let's pick this example only. How many lexicographically largest string there are? There is only this one, right? Taking the, let's say there are characters this here. Then this will also get included. These are the 5 positions that you'll have to choose. Not this thing. Now there cannot be any other lexicographically largest string or same. Even you won't get the same string even like at different positions. You'll get this is the lexicographically largest subsequence, and this is only one. If you are saying that there are two, then your lexicographically largest sequence is not correct. So coming back to this, now if there is only one lexicographically largest subsequence and you have to do operation on that only, and the operation is also fixed, then pretty much the problem is straightforward. The thing is, we cannot just brute force this because the time complexity won't allow us. Like we cannot just do this one by one by one by one and each time check for the sequence being sorted or not, like the complete string being sorted or not. But the thing is, we don't have to check every time. Why? Because we know that if this is the lexicographically largest sequence, we can change this only. And like I said, once I have done one operation, the next string will also have exactly one large lexicographically largest sequence. And let's say this was a C, this was a B, this was a A. Initially, this was the string. And after I do one operation, this is a C. I'll get A, C, B, A. The lexicographic largest string will now be this, and this is always valid. Like if let's say this initially you had some X, Y, Z, some Z, X, Y as your lexicographically largest string, Z, Y, X. It will be, first of all, it will be non-increasing. Why non-increasing? Why it should be non-increasing?
Because of largest lexicographical.
Yes. And the thing is, after you have this thing here, you will get X, Z, and Y. Then this will be your lexicographically largest subsequent. So now you have two things. You have for each, every time you know what is the, after every operation, you know what is the lexicographically largest string. And you also know the exact positions after one operation where these characters will go. The thing is, you don't need to check after each operation whether the string is sorted or not. If let's say there were some C's, then there were some B's, and then let's say there were some C's again, not some C's. But this is what I was saying. It cannot be. It is not possible that your lexicographically largest string looks like this. Like this is non-decreasing. This is increasing at this point, right? So if this is your lexicographically largest string, then your string is wrong. You should have taken this thing instead of taking these B's. So let's say, but your string was this thing. Now, why don't I need to check after each and every operation is because after one operation, these characters will shift to their new positions like this. This will go here, this will go here, this will go here. And finally, I know I have to do at least these many operations that these C's are at last. Eventually, these C's are at last, right? I have to do this much operations, right? And there is no point in doing further any operations. But these C's should be at least at last, as last as possible. So the thing is, why not just go up till that point and then finally see whether the string is sorted or not? Like let's do all the operations at once and then see whether the string is sorted or not. And if it is sorted, just find the number of operations. How can you find the number of operations? See, we know how many times we have rotated, right? If let's say how many times we have done this operation. If this character is not supposed to be here, then I would have done at least one operation to get this A here. For the next thing, I would have done two operations. Why two operations? For the first time, this C would have come here, and then the next time, this A would have came here. For this, it is 3. So like this, I can just count how many operations I would have done, and I'll get my answer. So if, like, should I show the implementation if the idea is clear? Like, just find the longest, lexicographically largest substring, subsequence, and then just find like do all the operations at once, because we know that, let's say this is our lexicographically largest subsequence. This thing, let's say these two are same. So this is ZZ. So this Z should appear here. This is what we know. So just do all the operations and bring them here. Finally, check what is the number of, like if the string is sorted or not. Like if this Z is here, this Z is here, you can fix all of these, right? And if it's sorted, then go ahead, print the answer. Otherwise, print -1. It's not possible. Okay, let's take ZBCA. So what is the lexicographic largest? ZB, right? So ZB, this is the lexicographic largest, right? So in one operation, first Z will come here. This I'll get Z, C, A, B. Eventually my Z should appear here. Then in next operation, this is my lexicographic largest. Like I said, these two will be left, like A, B, C, Z. Now my Z is here. Check whether the string is sorted or not. It's sorted. How many operations? For this, these are the places like which were involved in cyclic shifts. So for this, I would have done one operation. For this, I would have done how many operations? Two. And for this, you don't have to count. Why? Because once you have done these operations, finally your string would be sorted. You don't have to again try and bring Z here. It will be here only. So that's okay. Let me show you the implementation. So first take n as input, then take string s as input. Then this is how many times each character appears in my string s. This is just so that I can get the lexicographically larger string. Now this is a vector v. Then I'm going through each character, and for each time I'm finding what is the maximum character that is right now present in my string s. If it is the ith character is equals to that maximum character, then I'll include the ith character in my lexicographically maximum string, which is string t. This is the lexicographically maximum subsequence that I can get. If this is not true, I'll just simply decrease the count of the ith character one and I'll go ahead. Like this is just one way to get the lexicographically largest subsequence of string s. You can do this in many ways. Like this is one of the ways in which it's usually done. Then this is my answer. And like I said, I don't have to do any operations in that. Let's say there were two z's here. Then finally, like I would have got like two z's here. I should stop here. I won't do any operations after this point, because after this point, like the z's are already in this point. Like I don't have to do. Why will I swap this z with this z, and I'll do one more operation, right? So that's why I'm just decreasing at the start only. The character, like I cannot assume like z will be the maximum character in my subsequence, right? Lexicographically subsequence. So I'm going in reverse and I'm searching if this character is present in T, which is the lexicographically largest subsequence. I'll decrease my answer. First of all, it's 0. I'll just decrease my answer by that much, so that I can, like later on, like I'll simply just keep on adding, and I can break my subsequence. Like I'll break my loop. Finally, what I can do, if I'm going from 0 to n, if this character v of I is nothing but all those which were included in the largest subsequence string. So if that is in this, I'll just add answer plus plus, like I'll include this in my answer, and I'll remove this from my T. And like this is just one way to do those operations, right? Because of like I have to do these operations, right? I have to do these operations. I have to shift these one by one. So each time from my T, which is lexicographically largest subsequence, I'm bringing the last character to the ith place. Each time I'm doing this, so that I can get the final string, which I'll get after all the operations. And I'm increasing my answer by 1, like I have done here. For this answer will be 1, for this answer will be 2, because I would have done 2 operations up till now. So for this, I won't do anything. Like in my solution approach, I will do 3 here and I'll add 4 here. But I would have already started answer with -2. Then finally, I'm checking if the string S is sorted, that is after all the operation. If it is sorted, just print the answer that you get, otherwise print -1. So is there any doubt? Like you cannot directly print the lexicographically sequence and its size. First of all, it's not always possible that the answer exists. You need to find the string S that you'll get after all the operations. The second thing is directly printing the size lexicographically. Let's say this was the string S, you'll get the lexicographically largest subsequence size as 4, but the number of operations required is 2. Why? Like you need to decrease these two characters, like the number of times Z appears. So is there any other doubt? Okay, -1 case. -1 is the case when after doing all of see, your operations are fixed. You will choose those substrings only, subsequences only, which I have chosen like during these operations, and your operations are also pretty much fixed. So after doing all of those operations, even if your string S is not sorted, then there is no way that it will get sorted. You get my point? So in that case, your answer is simply -1. So at the last, we have just checked after doing all the operations, string S is sorted. If it is sorted, print yes, like print answer, otherwise -1. Is it clear? So let's take an example and I'll dry run also. Let's take this example, BAC. So let's say we have BAC. In this, what is the lexicographically largest string that you can get? C. Largest subsequence, it is C. Is there any operation that you can do on this? No. Like I said, you won't, like this is at this place and you want it at this place only. If we look at the subsequence, right? If this was the subsequence, we wanted this thing at the last. Like these characters should have appeared at the last. So now this C will be here only. Is this string sorted after the operations? No, it is not. So the answer is -1. Let's take another example. I have taken ZBCA. This will be a little big, but let's take this only. Okay, so what is the lexicographically largest string? Z. Then I think it will be N. Then I, then G, then E, then C. So the characters are Z, N, M, I, G, E, C. Z should appear here. So eventually your string like will be C. You did first operation. Then you will get the string as Z, N, M, I, G, E. Like I said, this is your now largest lexicographic sequence. Again, do one operation on it. Eventually, you will get something like C, E, G, I, N, M, Z. You replace these characters with these. C here, E here, G here, I here, I here, N here, M here. I think it will be MN. M here, N here, and Z here. So once you got this, check whether your string S is sorted. It is sorted. Then what will you do? Count the operation. So for this, you would have done one operation. For this, here, two operations. So answer is 2 here, 3 here, 4 here, 5 here, and 6 here. So as you can see, the answer that we get for this is 6. Is it clear? Total is 6. Like this 6 is, let me write again. This 6 is not for the last place. 3 for here, 4 for this I, 5 for G, 6 for E, not for the last. Because eventually Z will end up there only. Is it clear? And don't think that the answer is always lexicographically string.size -1. It's -1 when the largest character appears once. If it would have appeared twice, then it will be -2. So I think it should be clear now. Is it clear? Okay. So let's go to the next problem. So the next problem also requires a kind of observation, but let's see. So for an array A, let's define the cost as summation of 1 to n max of all the values from, like max of subarray from I 1 to I. Now we are given a permutation P of the set, this thing, which is 0 to n-1. And we have to find the maximum cost across all cyclic shifts of P. So I'm assuming that you know what is max, but like I'll give a brief description of this. A max is nothing but the smallest non-negative integer x such that x does not belong to the set. So I'll explain this in a moment. And a permutation is a simple random array that contains random arrangement of integers from 0 to n-1, and each integer appearing exactly once. So we need to find the maximum cost across all cyclic shifts of P. So this is to be noted that we cannot rearrange P in any fashion as well. It should be cyclic shifted only. So first of all, what is max? Max is nothing but if you have these integers, max of these would be the first non-negative integer, first non-negative or smallest non-negative integer, smallest non-negative integer, which is not part of these numbers. So max of this array or set is smallest non-negative integer, which is not part of this set or this array. Now a permutation is nothing but a permutation of size n, according to this problem, is nothing but arrangement of numbers from 0 to n-1. So we are given this thing, arrangement, a random arrangement of these numbers, and we can cyclically shift them. By cyclically shifting, we can just bring this n-1 here. So we can do these kinds of operation. So 210, yep. So we can do cyclical shifts, and we need to find what is the maximum cost, and cost is defined as for each I sum up, like let's say this is your array. For each I from 0 to n-1, like assuming the index starts from 0, you have to find max of this array, then max of this array, then max of this array, then max of this array, and you have to add them. And then finally you can print your answer. So if you're allowed to do only cyclical shifts, tell me what do you think if, let's say, there is a x here, what element should I look before this point? Let's say, first of all, let's pivot our array. Like let's make 0 here. Like let's bring 0 here, and this is our array now. Like I have cyclically shifted it somehow and brought 0 here. The thing is 0 is always in the in this array or in this permutation, right? 0 will always be in a permutation. So I have brought it at the front. So what is the minimum answer right now? Like forget about these elements. What is the minimum answer that I can expect?
0.
Why 0?
Smallest non-negative.
What is the max here?
Max
1.
is 0. 1.
No, maximum smallest non-negative integer which is not present in this. 0 is already present. 1. What will be the what is the minimum value of max that you can get here? You can at least get 1, if not 2. I'm assuming you'll get at least one. Here also you can get at least one. Here also you can get at least one. Here also you can get at least one. So technically the minimum answer should be n. Now don't say it could be n plus 1 also, because if I can put 1 here, like eventually for some array you'll get at the end you will get max of complete thing will be what? What will be the max of complete thing? It will be n plus 1. So don't say like even if I put randomly, it should be at least this. If I have a 0 here, it should be n minus 1 plus n plus 1. So which gives me 2n. I'm just saying it should be at least n. If 0 is fixed here, I'm not worried about any elements which are here. Right? Yes, no. So the answer should be at least n. Right? 0 is like I have pivoted 0 at the first place. Right? Now tell me if there is a x somewhere here, what all elements should I be worried about? Like what elements affect the max at this ith point? Let's say this is the ith. What all elements affect the max? This is the ith index. What all elements affect the max of this?
All elements should be less than x should be present in the 0 to I.
Yes, perfect. So all the elements that appear in this part and are less than I, they can, like they will only be included while calculating max. And let's say the previous element which was less, let's say that element appeared here, j. So this is kind of like assuming, like I'm not saying like from at this point to this point, like I'll get the max as x only. But this is one of the ways to solve this. Like just take the previous position which was less than the ith and assume that this was the max of all of these positions is simply x. Why? This is not always optimal. Like this is not always optimal, but the thing is, for each ith place, I'll calculate this exact same thing. Why? Because, and I'll add like whatever value, I'll calculate my value as, first of all, value of I will be value of j. This is kind of DP, but like you can do this in one go also. But let's say we are doing this in 2 iterations. First, I'll calculate for each I what is the previous smallest, like previous value which is smaller than j, which is smaller than x. What is the index of that? And also one more thing, I'll like I am taking the value up till j such that it is strictly increasing from, like the 0 is fixed here, so it will be something like 0 1 2. So 2 is here. I won't, or maybe 0 1 3, like strictly increasing up till this one. So whatever value like this, it can be here also if I have 7 here. So this is the previous value with like 7th index, which is having value, let's say 10, and x is having this value is 12. So just find the previous value, and value of I is nothing but value of j plus how many places are between 7 and ith. Let's say I is 9. So it is 9 minus 7, which is 2. These two places. And I'll assume that the max of, I'll get max as what? X here. X is 12. So for each value, for each I, I'll calculate like this. And eventually I'll get, for like when I'm doing this, I'll get the correct answer because I'll choose the maximum of those values. Maximum of values that I can get from 1 to n. Like let's say this is the previous lesser value is this. The previous lesser value is this. For this, the previous less value is, like I will take the maximum. I'll take the, for it will be, let's say this for it. will be, if for this I haven't written down, if it for this, let's say it is 0 here, it is 2 here, so previous less value is this, it is 1 here, and it is 3, 4, 5, but I want 2 here, so 3, 4, 5, 6, and I have a 3 here, so 6 is this, 3 is, what is the previous less value, this thing. So like this, I'll try to get for each index, I'll get the previous value, previous index which was lesser, and from that point I'll assume that the max is this. Now this is correct for some and incorrect for some other. Like for this 3, it will be correct. From this point to this point, you'll get max as 3 only. But for others, it might be wrong. Like for this, it is wrong. No, for this it is also correct. For this, it's wrong. You won't get 4 max here. You'll get 3 only. But eventually, when you come out here and you get the value from here, you add the max of like whatever the max value. Value is nothing but up till that point, what was the value of summation of maxes. So when you're at 3, you'll add this thing and the value here will be correct. And the thing is, we can always, like we have already arranged in this fashion, so the answer is always possible like this. Is it clear? Yes, no? Value I represents, like it's kind of DP, and I think like the DP hasn't been discussed. Like anyway, the batch has just started, and DP is, I think, it discussed in the second month. So yes, I'm discussing the intuition only first. So value of I is nothing but the sum of maxes that you can get and value of I is calculated like J being the previous lesser value how many values appear between these and the value the correct answer at the end will be maximum of value. Like this is kind of how DP works. Like it's actually what like majority of the people who have like whose solution you'll see, probably they would have done this in some other way, but deep down it's kind of DP only. Like we don't actually need this separate array. We can do this in one loop only. While I'm calculating the previous minimum, I can keep calculating the value also, and I don't need another array, and my answer will be nothing but for each iteration I'll just do answer is equal to maximum of answer comma value. Now some people might would have found that thing easier because you're not like you have not studied DP right now, but the thing is, like deep down, that this is the thing that is happening in that solution also. So let me show you the implementation. So first of all, I'm taking like n as input, then I'm inserting my all the values p in dq. Why dq? Because as I said, I need to bring 0 to the first place, and in order to do that, a dq is a best thing, like cyclically shifting, and each operation of removing a value from back and bringing it to the front is just O of 1 in dq. So just cyclically shift these values till you get 0 at the front. Now you have your permutation cyclically shifted and 0 is at the front. So now make a vector A. A is nothing but having all the values from your dq. This is your vals array, and initially everything is n. Like as I said, if 0 is at the front, you can get at least answer as n. Then this is the index of previous element which was less. So this is a very well-known approach. Just keep inserting in your stack And while the current stack is having size and the current element at the stack top, that is the previous element, is more than AI, just remove it. Finally, the previous element that is left in the stack is always, this is from 1, s dot top. And why I'm not checking whether the stack is having size or not? Because there is no way that the stack will get completely popped out. Like all the values will get completely popped out of stack. Why? Because the first value in the stack is 0. I need to put it here. Like the first value will be 0, and it is the value which is 0. Like array is having 0, right? Array is having 0. I think if you start from 0, then it will get eventually pushed here. And otherwise, if you push 0 here and start from 1, then while the stack is having size and a of s dot top is more than this, you'll remove that value from your stack. Eventually, there will be at least one value left. Why? Because at 0th index, the value is 0 because of cyclically arranging them in such order. Eventually, p of I is nothing but this is index of I is nothing but the value which is previously less. Then what I can do, I go from 1 to n, and vals of I is nothing but vals of index of I. Index of I is nothing but this is j, previously less. I minus index of I, this is I minus j. Why? This is the number of values which is between j and I, for which I'm assuming that the max is ai. Finally, I'm printing maximum of max element of this and n. I don't think I have to take n here. Like, while coding, I would have taken it, but it is not required because I've initialized my vals with n. Like there is no way that the value here would be like, I need to check if either it can be less, but I don't think this is required, this extra n. Finally, we can print the maximum of this thing. And of course, the answer can at least be n. Like it won't be less than n. Is it clear? Yes, no, anything. How many people have actually used stack before? Yes, stack is used to find the previous. Like this is a very well-known algorithm. Like if you have to find previous minimum, previous maximum, we always use stack because it is O of n. So how many people have actually used stack before? Not many, huh? So stack is used for finding the previous maximum, minimum, or the monotonic sequences of maximum length. So this is what we are kind of doing here. And this is other than that, this is a straightforward DP part. So, okay, I don't think there are any other doubts. So feel free to drop off, and thanks for joining. Okay, bye-bye.